Welcome to the Dallas Independent School District STEM Environmental Education Center, and special welcome to the second graders at Martha Turner Riley. Thank you for joining us today and registering for this field trip. If you have not registered for this field trip, you still can by going to www.tiny.cc/EEC register to register for this field trip. It just helps us out with keeping track of attendance, is why we have people register. Today's field trip is going to be about classifying objects. So during this virtual field trip, students will discover that matter has physical properties, and those properties determine how it is described and classified. The properties we're going to explore today are temperature, determining whether a substance is a solid or liquid, texture, and flexibility. And while we explore these physical properties, we're going to use some tools. We're going to use a thermometer, a hand lens, and a flask. So keep a lookout for those tools as we do today's field trip. If you have any questions for us during the field trip, you can submit those by going to www.tiny.cc/EEC-question-answer, and you can ask us any question you like and ask as many questions as you like, and we will do our best to answer all of your questions during today's trip. So without further ado, I'm going to stop sharing my screen here and turn it over to our first teacher, Mr. Monroe, who is going to discuss solids and liquids.
Good afternoon, second graders. Before I get started in our investigation of whether a substance is a liquid or a solid, I want to remind you students that anything that takes up space is considered to be matter. And those properties that matter has, Mr. Barton has also mentioned, but you know, it's actually how an object looks, feels, or acts. Today, you're going to be doing an investigation with me on determining whether a substance is a liquid or a solid. You know, when we talk about a liquid, we're talking about, is it running? Can it be poured? Particles that make up matter. These particles are referred to as being building blocks of all matter. In fact, we call them atoms. And in a liquid, those particles are loosely packed together. So there is no definite shape of a liquid. Take, for example, day before yesterday, it was raining. Stepped out in the rain, and the rain was coming down pretty hard, and I could feel the raindrops hitting me on the head. And you know, I'm sure that while that raindrop was falling, it was in the drop form. But once it landed on something, did it keep the same shape? I don't think it did. I think it flattened out and maybe it ran somewhere. What about you? You think it was like that? Well, that's what a liquid is all about. You know, it has no definite shape of its own. And I'm going to use a liquid that is in this picture. And we can see, kind of reminds me of something I used to drink when I was a second grader. They called it Kool-Aid, but this is not Kool-Aid, guys. Also, I'm going to be using a glass container that we use here in the lab. It is called a flask. I'm going to pour some of this liquid into the flask, this substance. Looking at both containers, did it keep the same shape that it had in the pitcher as it went into the flask? No. So when a liquid is being poured into another container, it takes the shape of that new container. That's one way you can tell whether a solution is a liquid or a solid. And I'm even going to go a little further. This flask is marked off in measurements. If we look at this, there's 100 here, 200, 300, 400, 450, 500. And most likely this is 550. Now, those units of measurement are in what we call metric units of measurement, and they are called milliliters. On the other hand, I have a mason jar here. This mason jar has some measurements on the side of it, except these measurements are customary measurements. Is the liquid going to change shape again? I believe it did. It's now shaped like the mason jar halfway up, okay? Now, actually, I'm looking at this and I see that I have actually poured to this mark a little bit above, but this mark is actually a customary mark that would say the volume of the solution in this jar is pretty close to 1 cup. Makes me think about every morning when I get ready to come to work, I drink 1 cup of coffee per day. So that's about a cup. On the other hand, when we talk about a solid, we're talking about something that you can grab onto and you can hold, you can feel it. You know, if I was to stick my hand in this solution and try to grab it, it would run right through my fingers and right through my hand. I wouldn't be able to hold on to it, right? Well, I have a rock here. And this rock is one of my favorite rocks when I'm teaching about rocks to talk about. This rock, I'm able to hold it, feel it, and I can tell you it's kind of heavy. This rock is made up of a mineral that resembles something that people used to look for a long time ago when they were trying to get rich. It looks like gold. But the real name for this rock, or the nickname for it, it is called fool's gold. Because back then, if someone found a rock like this, they would get all excited thinking that they had found gold. When they took it in and had it tested, their hearts were broken and they found out that they had found something called fool's gold. In other words, they had found iron pyrite. Okay? That's a solid. You can hold on to it. I have something else I want to show you. These are bones. In fact, these bones are very old. I can hold on to them. I can feel them in my hand. They're not going to run through my fingers. They're right there for me to hold on to. And you know, if we look at these bones, they kind of resemble a body part. Now, I will tell you, this is the body part. It is the remains of an animal that lived thousands of years ago. So we would call this a fossil. If you look at this, what body part do you think this might have been part of that animal that lived long ago? Well, I can tell you, doesn't that look like a toe? In fact, it is toe bones from a very large elephant that lived thousands of years ago called the Columbian mammoth. And these were found right down the road from here in a dig. I can hold on to it. It's solid. The particles of this, the atoms that make up this matter, are tightly packed together. They don't move. Now, I know there's a bit of confusion sometimes, but a lot of times when people see live things, they don't realize that live things basically are solids too. For example, I've got my little friend right here. This is a 3-toed box turtle. I'm holding it. It's in my hand. I'm holding on to it. In fact, if I didn't hold on to it, it would probably crawl right out of my hand. It has a definite shape. And believe it or not, it's made up of atoms also, because it is matter. Okay? Now, because of that, because it's matter that takes up space, we can measure it using numbers to get a measurement. Even with the liquid, we can use numbers as I showed you. Now, the measurement that we would use with the liquid is something called volume. A cup, 550 milliliters, that's the volume of what we measured that solution to. Now, we could simply use a tool like a ruler to measure Teresa's shell. But I'm going to show you a new tool that we're going to use today. It is called a caliper. I'm going to measure how long her shell is by simply putting one end of the caliper right there and the other end at the far end of her shell, And I can tell you the length of her shell is roughly 5 inches long. That's the customary measurement. And 130 milliliters, which would be the metric measurement of her shell. I also am very curious about how how thick she is. So I'm going to measure how thick she is by simply putting the caliper there. And I can tell you this, she's 3 inches thick as far as her curve of her shell and the bottom of her shell. Okay? So hopefully what I have helped you with right now is to be able to determine whether a solution is a liquid or a solid. Remember, liquids are running. Their particles are very loose, so they do not have a shape of their own. They shape whatever the shape that they're going to have is in whatever container that they're in. On the other hand, solids have their own shape, like Teresa, like the toe bones of the Columbian mammoth, and the rock. I want to thank you for your time, and hopefully what I've done with you has been an instructional way to where you can determine whether a solution is a liquid or a solid. If there are any questions, I'm now going to turn it over to Mr. Broughton so he can answer those for you. Thank you.
All right, thank you, Mr. Monroe. And there was one question, which is slime a liquid or a solid? And that is a very good question. I know kids love to play with slime. Imagine if I had some slime in this mug here, and maybe it was like this high up. It would be kind of a cylinder shape inside my mug. And then if I took this beaker here, which you can see is quite a bit wider than my mug, but still a cylinder shape, and I poured the slime from my mug into the beaker, it would take a while to finally pour out, because slime doesn't move quickly like water does or other liquids, but it would eventually go in and it would take up the whole bottom of this beaker and be another cylinder, but not the same shape cylinder. It would be shorter and wider. And then if I poured that slime from this beaker into this flask, it would go in there eventually, but it would be kind of a cone shape like this flask is. So being that it does take the shape of any container that it's in, slime would be classified as a liquid. It's not as runny as water, but it is still a liquid. All right, we're going to move on to our next property, which is texture with Mrs. Fuller.
Good afternoon, second grade. We're going to be covering TEKS 2.5, matter and energy, classifying matter by physical properties. The physical property we're going to look at in this segment of the program is texture. Texture is how something looks and how it feels. Now, this is my friend, Lauren Aracana. She's from South America. She lays green eggs, and she can fly. She can fly a little bit. Now, what I have here is a feather, a flight feather. Only birds have feathers, so we know that she's a bird because she has feathers. This flight feather is very smooth. It needs to be smooth for the bird to push against the air in order to fly. So look at her wing. You can see she has flight feathers. Like I said, she doesn't fly very far, but she can fly. So this smooth flight feather helps the bird to fly. Another type of feather that helps with flight is a contour feather. If you'll look at birds, they have very smooth bodies. They've got contour feathers that cling to their body. It helps them slip through the airstream. So a smooth contour feather is going to help her. Now, in science, when we observe using our five senses: sight, smelling, taste, hearing, and touch. So I touched the chicken to see how smooth she was. I looked at the chicken. I saw how smooth she was. I take the hand lens. Indeed, she is smooth. So we're going to put her down, and we're going to look at an animal that is rough. This rough animal is a gecko. His name is Peanut. Can you see Peanut's sweet face? Peanut is very rough. Look at those bumps on his back. These bumps help him be successful in his environment. So when I touch him, I can tell Peanut is rough. When I look at him, I can see the bumps. When I take the hand lens to inspect him, he is very rough. So these rough bumps on him help him be successful. That's the texture of the skin of Peanut, the gecko. We'll put him down. So we talked about smooth and rough. Now let's talk about soft and hard. This is a pelt. A pelt is the skin of a mammal that still has the fur on it. This particular pelt is a bobcat. We've got 5 different kinds of wild cats in Texas. Bobcats are the most common. We also have pumas, ocelots, margays, jaguarundis. Those other 4 are very rare. But even though they're more common, most Texans never see a live bobcat because they're extremely shy. They don't like to be seen. But I can tell by touching the pelt of this bobcat that this bobcat is extremely soft. I can take the hand lens, examine that soft fur, and tell you it's a very soft fur. Let me hold it up to the camera so you can see how soft the fur is on the bobcat. It has very soft fur. I can tell by touching that it's very soft. This soft fur helps the bobcat be warm in the wintertime. Now, in contrast to soft, we have hard. So I have a turtle shell here. Now I'm going to show you the turtle shell so you can look inside. It's empty. There's no turtle in there. The turtle has to be inside the shell in order to be alive. His backbone is embedded in the roof of this shell on the inside. So if he's not in here, he's not alive. He's not out running around somewhere. He has to be in here in order to be alive. By touching the shell, I can tell it's hard. By looking, I can tell it's hard. When I look at it with the hand lens, oh yes, it's hard. I can even tap it with my fingernails. This is a hard covering. Now, I'm going to show you a turtle that is alive. This is a 3-toed box turtle named Terrence. I'm going to show you his sweet face. Say hi, Terrence. Terrence has lived in my lab for a very, very long time. Terrence has a very hard shell. This hard shell protects him from predators. This animal can pull up inside himself inside a box, and that's why it's called a box turtle. So we're going to put him down, but he's got a hard shell. So we saw the texture of soft, the texture of hard. Now we're going to look at the texture of some rocks. Now, the 2 textures we're going to look at on rocks are coarse and fine. Coarse means large, fine means tiny. So the first rock we're going to look at is a sedimentary rock called pudding stone. That's what the pudding stone looks like. It's got a coarse texture, a coarse grain. I can tell by looking at it to see all the big crystals and all the big pieces of rock. I can feel it, feel how coarse the grain is on this. I can take my hand lens and look at it. Oh yes, this has got a very coarse grain, this pudding stone does. In contrast to the coarse grain of the pudding stone, obsidian has a very fine grain. So here's a piece of obsidian. It's very heavy. I can feel it, but I don't feel the grain. I don't feel any crystals. I can look at it. I don't see any crystals. I can examine it with a hand lens. I can't even see crystals with a hand lens. They're too fine. They're too tiny. So this example is an example of a fine grain or fine texture, and the pudding stone exemplifies a coarse grain or coarse texture. I'm going to turn this back over to Mr. Broughton, and he's going to explain to you about other textures. So, Mr. Broughton?
Yes, we had a question, which is, what are all the textures? And there are too many textures to name, because remember, anything that you see or anything that you can touch has a texture. So if you think about all the things you've seen and touched in your life, that would be a lot of things and too many to talk about today. But I will share one texture that I think is interesting. And let me just share my screen here and go to this slide. This is a picture of a wall, and you've probably seen something like this in your home or apartment or school. They texture walls when they build a house or an apartment. And this kind of texture you can see has some bumps, but then the bumps are kind of flat on top too. And whoever came up with this texture looked at it and they touched it and they thought it kind of felt like the peel of an orange. So this texture is called orange peel. And so that it's kind of, you'd never think of orange peel as a texture, but there it is. So there are many, many other textures, too many to name, but at least we saw one other one. And now we are going to move on to the next property with Miss Nash.
Hello, second grade. Welcome to my classroom. And today we're going to be exploring the property of flexibility. Flexibility just means the ability to bend. The opposite of flexible is inflexible, not flexible, or rigid. So we're going to be contrasting those two properties in some different things today. Now, you look around your house and you probably find some things that are flexible and some things that aren't. And being inflexible is useful sometimes, and being flexible is useful sometimes. So I got my chopsticks here, and I can pick up my rock with my chopstick. But if I try to use these straws, it's not going to work. It doesn't work. They don't work. They work for other things, so they're very flexible. Have a really thin wire inside it. Now here's some straws, two different straws. So this straw, if I bend it, then I can't use it anymore. I can't suck up my milk with it. It doesn't work anymore. But some smart person looked at that and thought, I can figure that out. And they made, you ever seen this kind of straw? A little joint here that can bend. So this one still works, even though it's bent like that. Sometimes the difference between flexible and inflexible is how much stuff we have. So this paper, one single sheet of paper, is very flexible. But if I have a whole package of paper, I can't bend that. It's rigid, inflexible now. These spoons. This one is kind of thicker, and if I try to bend that one, I can't do it. This one is a lot thinner. Can you see it's thinner? And I can actually kind of bend that one. My plastic spork here is quite easily bent, but it's still pretty strong. So if I have a plastic spoon spork, it'll hold my rock. However, if I had a paper spoon I made, that just doesn't work. Sometimes the thickness of natural objects. So a lot of natural objects are very flexible. So sometimes again, it's about a matter of the thickness. So this little thin stick is very flexible, and also it's green. So it was alive a little while ago, and it's very flexible. The thicker one here, same plant, but thicker, is much less flexible. And a dead one, I can't bend it at all. I could break it maybe. So it has to do with being living or dead. Now we people, humans, who are so smart, we figured out that, that's useful. I can make something out of it. And we take green plant material or soak it in water so it gets very flexible. And then we can make a basket. And when all that grass or whatever reeds dry, then it's very strong again. So birds do the same thing. They use flexible material to make their little nest. All those nice little grasses in there. And I think that the first person to make a basket got the idea by looking at a bird's nest. And they thought, I can do that. I can take some grass and plants and I can make like a little nest like the bird does. And I can keep things in it. And they invented the basket. So plants are flexible. It's kind of a trade-off though. Like a tree. If you watch a tree in the wind, it's got to stand up. It's got to be somewhat inflexible, but yet it has to bend with the wind or else it'll just break. So plants are often quite flexible, and so are animals. So we're quite flexible. The big bones in our body are not. They would break. But where each bone meets another, that's where we're flexible. So if you look at your fingers, you have those little joints, 1, 2, 3, and you can bend your fingers. And so you can play the piano. If you couldn't bend them, it would be very hard to play the piano or do much of anything. So we can be very flexible, and so can other animals. The champion of flexibility in the animal kingdom is our friend snake. Not this one, because it's made of wood, but a live one, like my friend Red. Now this is Red, and he's a rat snake or a corn snake, and he's very, very flexible. He has this amazing body. He can move all around. He can almost tie himself in a knot. And that body shape helps him go down a burrow or through the tiny spaces in the grass or behind bark. They can climb trees. They're really amazing, beautiful animals. It also helps him when he catches a rat or a mouse. He can wrap it around it to suffocate it and then eat it. So this very flexible body is truly amazing. And sometimes children come and they say, I don't think they have any bones. Look how they move. And of course, when we look at the skeleton, we see they have a lot of bones. They don't have any leg bones or arm bones anymore, but they've got lots of bones. They've got bones in their head, bones in their tail, and then all down the body are all these vertebrae, and 2 ribs on each one, and where each vertebra meets the next, they can bend. And we have those same bones in our back, so that's why we can bend over and do a back bend maybe, if you're that flexible. So being flexible really helps the snakes. They're the champs, the champions of being flexible in the animal kingdom. Maybe the octopus would be equally flexible. But I don't have one. Okay, Red, let go. There. Let me put Red back real quick. Because that little body makes the master's escape also. So now, my challenge for you is to go around your house and make a list for me of 5 things that are flexible and 5 things that are not. They're inflexible or rigid. And then you can list those 5 things, make a list, and then tell me how that property helps that thing be useful. So the 2 examples I made for my house were my hammock out in the yard, and it's flexible. That makes it more comfortable when I sit down in it. The strings kind of give, okay? They kind of wrap around you, keep you from falling out. But my chair that I'm sitting in right now, I want it to be rigid or else it would just collapse under my weight. So you can go around the house and see if you can find 5 things that are flexible and 5 things that are rigid. And then tell me why it's important for them to be either flexible or rigid. Okay, thank you very much, and I hope you enjoyed your afternoon with us, and I'll turn it over to Mr. Rotten for a question.
Yes, so the question that we got was, am I flexible? And yes, you are. Miss Nash explained that humans are flexible, not as flexible as a snake, but we are flexible. I mean, you can move your body parts, you can bend your fingers a little bit, you have flexibility in your body. But it is important to maintain flexibility in your body because as you get older, you might become less flexible if you are not exercising and stretching every day. So maybe talk to your physical education teacher about that. Ask them about flexibility, and they will know some exercises and things that you can do to stay flexible your entire life so that you live a long, healthy life. All right, next we are going to explore temperature with Mr. Ramirez.
Happy Friday, second graders. Welcome, my name is Ms. Ramirez, and in this segment, we're gonna learn all about the property of matter called temperature. So temperature is simply the amount of heat that an object or the surrounding air has. And it generally can tell us if it's hot or if it's cold. So if I were to show you this cup of ice cubes and my hot tea, what are some temperature words you can say to describe these two objects? Well, lucky for me, since I'm able to hold them, I can use my sense of touch and get a relative temperature. I can feel that my tea is warm and that this cup of ice is really cold. If I wanted to be a good scientist, I can actually measure the temperature using a special tool called a thermometer. So I'm going to show you what a thermometer looks like, and then we'll practice reading one. So this is our sample thermometer. Make some observations. What do you see or notice? How do you think the thermometer works? So in our thermometer, we have a bulb at the bottom, and it has a long stem. Inside the bulb and stem is a liquid. It's a type of alcohol, and it's dyed red so that we can see it easier, so that we can read it better. And what ends up happening is when it gets warm outside, the alcohol inside will expand, and it has no place to go except for up. Then when it cools down, the liquid contracts or shrinks, and then it ends up going back down the thermometer. So to demonstrate the expansion and shrinking of the liquid, we're going to look at our hand boiler here to show how that liquid moves. Now it's going to work off my body heat, so let me try and warm my hands up a little bit. Sometimes I can get the liquid to go up super fast, and then other times it goes really slow. So I'm trying to create some heat or friction by rubbing my hands together, and then we'll see how our hand boiler works. So I'm just going to cut the ends, and you'll see that the liquid inside is starting to rise to the top. So it is expanding, similar to a thermometer. And then we see it appears to boil. You start to see bubbles. I know it's called a hand boiler, but the liquid inside is not technically boiling. What you see happening is the ethanol vapors are simply coming up to the top, creating those bubbles that you're seeing here. So this is just a good demonstration to show you how that liquid moves within a thermometer. So now let's make some other observations with our thermometer. We see it has a big C and an F. C stands for degrees Celsius. F stands for degrees Fahrenheit. Now, a very important number for us is, if we look on the Celsius side, we have the 0. 0 degrees Celsius is actually the degree at which water will freeze. Now, if we wanted to get the Fahrenheit equivalent of the freezing point, all we would have to do is just follow that 0 across to the other side, the Fahrenheit side, and then count the increments. So if this is 20, that means this dot is 30, and these little lines in between are in segments of 2. So if this is 30, this would be 32. So water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. And that's important to know because once it reaches 32 degrees Fahrenheit, we really have to be careful when we're traveling because we want to avoid the ice or sleet that might be on the roads. Now for us at the EEC, Temperature is very important because our animals need the correct temperature in order to help them stay healthy and alive. So for example, I have a reptile friend. His name is Riley. Riley is a cold-blooded reptile. He is a Russian tortoise, and he is very dependent on temperature. Cold-blooded animals cannot regulate or maintain their body temperature like we can. Humans and other mammals are warm-blooded, so our body temperature stays pretty much the same. It's pretty good at maintaining itself. For a human, the average temperature is about 98.6 degrees, give or take a few degrees. So we're pretty good at maintaining the body temperature. However, cold-blooded animals, their body temperature depends on the outside environment. So as a pet, they live in a habitat like this. It's called a terrarium. The terrarium has a warm side with a heat lamp and a cool side with no heat at all. So if he's feeling a little cold, he might migrate his way over to the warm side and bask underneath the heat lamp to get warm. Once he's warmed up, he might make his way back over to the cool side. So that's why it's important for us to know about temperature, because our animals depend on it. Now, what about the wild reptiles that live outside? How do you think they are able to control their body temperature? What do they have to do? So think about that. I'm actually going to go around and we're going to look at the temperature and compare the temperature on the cool side versus the temperature on the warm side. So what do you think the temperature difference is going to be? How hot do you think it's actually underneath this heat lamp? So on this thermometer, this is the cool side. I put a ribbon on it so that we can remember. And I can feel by just sticking my hand underneath that heat lamp that it's nice and toasty on that side. I'm going to walk around my chicken because she's on the floor. Okay, so let's look at our thermometer. So this is the one from the heat side. Look how far that liquid went up, all the way up here. So it's about 100 degrees Fahrenheit. That is quite warm over there on that basking side. Now let's look at our cool side thermometer. It's about 80 degrees Fahrenheit. So what's the difference? So 100 minus 80 is 20. So it's about 20-degree difference from the warm side to the cool side. So that's why temperature is important to us here at the EEC. It's for our animals. Now let's make a trip outside to look at a thermometer outside and think about why is it important for us to learn about temperature and how does temperature relate to us as humans. So let me just flip our camera around. We're gonna walk on outside. There's my chicken that almost tripped me earlier. We're gonna go ahead and head out the door. It's such a lovely day today. It's not as hot as it has been in the past. We have our windmill blowing in the wind, and here is our thermometer. So we have degrees Celsius and degrees Fahrenheit. So let's read it. Here is the 80 mark. This is 90. So let's do, so these are going by twos. So 82, 84, 86. So it's about 86 degrees Fahrenheit. Or if we wanted to get a Celsius reading, it's about 28 degrees Celsius. Now let's go to the other side. I have another thermometer. This thermometer says it's about 92 degrees Fahrenheit. So oftentimes I get asked, why do I have so many thermometers? That is because the temperature will actually differ depending upon the location of the thermometer. So why do you think that is? So depending upon whether the thermometer is placed in direct sunlight or if it's in the shade, we'll get a different reading. So to review, temperature is just a measurement of heat. So it's going to tell us how hot or how cold something is. And the tool that we use to measure temperature is simply a thermometer. So before I let you guys go, I have two tasks for you. The first is to see if you can create a word cloud about the word temperature. See how many words you can write to describe temperature. I already gave you a head start. I wrote the word cool down. Yesterday was very cool in temperature. Today it's still cool, but it's warmed up quite a bit. My other is a reflection question. I want you guys to think about this statement and tell me if it's true or false. Objects can only get hot by touching something. So is that statement true or false? And then explain your answer. So if you need help answering that question, think about some of the heat transfers you saw in today's lesson. And that is all I have for you guys today regarding temperature as a property of matter. So we're going to go ahead and give it back to Mr. Broughton, and he's going to answer any questions that you might have.
All right, and the question that we received was, what is inside a thermometer? And the liquid that is inside most of the thermometers that you'll see at your school is a kind of alcohol. Alcohol expands really well when it heats up, which allows that liquid to move up the tube inside a thermometer to show that something is warmer. And it contracts when it gets cooler and goes back down to show something is cooler. Now, people used to use mercury in thermometers, which is another kind of liquid, but that is a very poisonous liquid. So they stopped using mercury because once in a while a thermometer breaks and then that liquid comes out, and you don't want to be poisoned by mercury. So alcohol is much safer than mercury, which is why we use alcohol today and not mercury anymore. Let's take a little review here of what we did today. So I'm going to share my screen with you again. There we go. And so today during this field trip, you discovered that matter has physical properties, and those properties determine how it is described and classified. You learned that you can measure the temperature of matter. So you can measure the temperature of the air or a liquid or a solid if you put a thermometer up to that solid. You can also classify matter as being a liquid or a solid. And we learned about textures. There is hard and soft, rough and smooth, and coarse and fine are kind of your 6 major textures that you need to know. We also explored flexibility. So if something is flexible, that means it's able to bend without breaking. If it cannot bend or it breaks easily, then it is rigid. And we used some tools today. We used a thermometer to measure the temperature, a hand lens to look at different textures, and a flask to hold a liquid. So thank you so much for joining us today. We're glad you were able to do that. We would like to know what you think about our field trip, so you can give us feedback by going to www.tiny.cc/EEC feedback to let us know how we did. We're always looking for ways to improve what we do, and we value your feedback, and your feedback is one of the major ways that we do improve what we do. So with that, I'm going to stop sharing my screen and wish you a good rest of your afternoon. Bye-bye.